Hello, this is the class for Wednesday, April 1st. We're still in section 10.1, talking about trying to estimate one proportion from a bunch of data. And today we're going to move on to a different type of analysis called the hypothesis test. So I'll start with a new example. Suppose that we're playing a video game and we're playing the same mission in the video game over and over. And the reason that we're playing this mission is because when you finish the mission, there is an item that we're trying to collect and we need a bunch of it. So the good item is supposed to drop at the end 1/3 of the time. Okay, so the prize you get at the end of this mission is random, and there's only really one of the random prizes that we want, and the probability that the good prize drops is supposed to be 1/3. But today we have some bad luck. So in 20 runs through this mission, we only get 3 of the good prize. On the other 17, we got something else that we didn't want. So the question is, has the drop rate of the good prize been reduced? You know, because maybe this is an online game, the software developers can tweak things. You know, have they changed it so that the good item doesn't drop as often, or did we just have bad luck? So what we're going to do is say, well, what do I mean by bad luck? How bad was our luck? Now, this is a binomial distribution type situation. We repeated this, basically this this experiment had 20 trials, and out of the 20 trials, we got 3 successes. So using the binomial distribution, we can figure out what is the probability that we get 3 of this prize. So the probability of a 3 coming out should be 20 choose 3. So my word is running slow here. Okay, I guess that's not what I want. Not matrix, it's a bracket. Bracket. Okay, so we want 20 choose 3, and then it's a 1/3 probability of the thing we want. We had 3 of those, and there's a 2/3 probability that we don't get what we want, and we had 17 of those. Okay, so I did this ahead of time, and it comes out to about 4%. So 4% is pretty unlikely, but not outlandish. But you know, there's 20 different numbers that could come up, and even the most likely ones are not going to be big numbers. Like, you know, I guess the most likely number is maybe a 7, right? Because 1/3 of 20 is 6 2/3, so the closest number is 7. And even with a 7, it's not like that's going to come up like, you know, 60% of the time. It's still going to be a relatively small number. So rather than just looking for the probability of 3, let's think of, well, what are the probability that we get a 3 or something even worse? So it would be even worse if we only got 2 prizes. And so that would be 20 choose 2, and then the 1/3 would have a power 2, and the 2/3 would have a power 18. This one turns out to come out to about 1%. And it would be even worse than that if we got a 1 or a 0. So the probability that we only get 1 of the prize is less than 1%, 0.003, and the probability that we get none of the one we want is 0.003, quite unlikely, 3 out of 10,000. Okay. Now, if we add all of those up, that would give us the probability that we get something as bad as 3, you know, 3 or something even worse. Now, before I add those up, I'm actually going to go one step further and say, well, we know that the mean is 20 divided by 3, which is 6.66666. So getting a 3, how far away is that from the mean? it's like 3 2/3 below the mean. So it would be just as unusual to get a number of prizes that was 3 2/3 above the mean. Okay, I mean, we'd be happy with that because we're getting more prizes than we expected, but it would be just as unusual. So that puts us like a little, like if you add 3 2/3 to this, you get something a little more than 10. So like an 11 would be more unusual than getting a 3. So like what's the probability that we get 11 prize drops? That turns out to be 0.025 if you plug 11 into this formula up here. And it would be even more unusual to get a 12 or a 13 or a 14 or any of those numbers that are bigger. So 12, it turns out, is 0.09, and then 13 and 14 and 15. So we could sort of like, we could find out all of these and so on. I'm not going to write them all down. Okay, so why don't we include those in the sum? So even though the ones that are 11, 12, 13, and more, even though those are things that are unusual but we're happy about, whereas the low numbers are unusual but we're unhappy about, just to get an idea of how unusual it is to get a 3 out of 20, maybe we can take the probability of a 3 and then also the probability of all the outcomes that are even less likely than that. So the ones that are less than 3 and also the ones that are 11 and more. So that's sort of like all of the possible outcomes that are 3 or something even less likely than 3. Okay, so let's add up all the possible outcomes from, okay, so including 3 and all outcomes less likely than 3. That gives 0.098, so just shy of 10%. Okay, so 10% is kind of on the low side, but it's not crazy low. You'd expect that to come up sometimes. If you're playing this game a lot, then it's going to happen, on average, one every 10 times you do this thing, 20 times through this mission. So it's not that crazy. Well, what we're kind of doing here is something called a hypothesis test. So how a hypothesis test works is we have something called the null hypothesis. Our symbol for that is going to be H with a subscript 0. So I'm just going to write, how about like that? So H with a subscript 0 is what we're supposed to have there. Okay, so this is sort of the conventional wisdom. So this is the default assumption. In our case, it's that the drop rate is 1/3. So in our example, that P is equal to 1/3. And we are trying to basically check if this is true. We want to check if this is true. And then there's going to be something we call the alternative hypothesis. So that's going to be HA. So this is pretty much what happens if H is not true. So if our null hypothesis is not true. So in our example, the alternative hypothesis is that P is not 1/3. Now that's a pretty broad statement. When I say P is not 1/3, I'm not saying that it's 3 out of 20. I'm just saying it's anything other than 1/3. It might be a smidge under 1/3. It might be something bigger than 1/3. It might be well under 1/3. The hypothesis test is not a very precise test in the sense that, like, the question it answers is very broad. It's basically, here's the number that we think is, that we're told is true. We want to check if that's true. And we either say, yes, it's true, or we say, no, it's not true. And if it's not true, we don't know what it is. It could be anything else. All right. So the way the hypothesis test works is we use the proportion p from the null hypothesis. So the null hypothesis is that the probability of an event is a specific number. Using that proportion, we find the probability that our sample could happen. Or something more unusual. So that's what we did, right? We didn't just find the probability that we would get 3 drops out of 20. We found the probability that we would get 3 drops or something even more unusual than that. This number is called the p-value. Now, it's a little bit unfortunate that this is called the p-value, and we're looking for a proportion p, and our sample has a proportion p hat. There's p's sort of all over the place, but that's life. So the p-value we found for our example up here was 0.098, so just under 10%. So if the p-value is very small, that means that our sample was really unlikely to come up. At least it was unlikely to come up under the assumption that the null hypothesis is true. So if our p-value is very small, it means one of two things. It means either our sample is very unusual, and either we got, however you think of it, very lucky or very unlucky that that sample happened. So either our sample is very unusual, or the null hypothesis is false. Okay. So if our p-value is very small, it really has to be one of those two things. Like either the p-value is true and it's just a really weird sample, or I mean, either the null hypothesis is true and it's just a really weird sample, or the null hypothesis is actually not true. Okay, so when the p-value is very small, we can say like, okay, so maybe the sample is very unusual, but we have just found evidence that the null hypothesis is actually false. The smaller the p-value is, the stronger the evidence we have the null hypothesis is false. Okay, so that's how, like, the general idea of how a hypothesis test works. It doesn't prove anything. It just sort of provides evidence. You find your sample, you find the probability that that sample could happen. If that probability is very small, maybe you just hit that small probability and the null hypothesis is still true, but you have some evidence that actually maybe it's not true. Okay, so we are going to do some examples, but I've been talking long enough, so I'm going to stop this video. We'll put the examples in the next video.